Example 4, a function from physics. Although a formula of the form g of x is equal to the integral of f of t dt from a to x may seem like a strange way of defining a function, books on physics, chemistry, and statistics are full of such functions. So for instance, the Fresnel function, capital S of x is equal to the function the sine of pi times t squared divided by 2 dt from 0 to x, is named after the French physicist Augustin Fresnel, who is famous for his works in optics. This function first appeared in Fresnel's theory of the diffraction of light waves, but more recently it has been applied to the design of highways. Now, part 1 of the fundamental theorem tells us how to differentiate the Fresnel function. So what we're going to do is we're replacing the upper limit x, which is t, is now going to become that following. So we can say that s prime of x is going to equal the sine of pi x squared divided by 2. And so this means that we can apply all the methods of differential calculus to analyze s. Now the figure below shows the graph of f of x, which is equal to the sine of pi x squared divided by 2, and the Fresnel function that we saw here, which is the integral s of x, which is equal to f of t dt from 0 to x. So you can see here that here is the function f, okay, and then here is the integral s. Now a computer was used to graph by computing the value of this integral for many values of x. It does indeed look as if s of x is the area under the graph of f from 0 to the value of x, until x is approximately 1.4, when s of x becomes a difference of areas. The figure below here shows a larger part of the graph of s. So this represents the Fresnel function. If we now start with the graph of s in the first figure and think about what its derivative should look like, it seems reasonable that s prime of x is going to equal f of x. So for instance, s is increasing when the function f of x is greater than 0, and it's decreasing when f of x is less than 0. So this gives a visual confirmation of part 1 of the fundamental theorem of calculus.